Okay, today we're looking at section 5.3, which is second day of slope-intercept form. Hopefully by the end of this lesson you can say I can write a linear equation using slope-intercept form, and I can graph linear equations using slope-intercept form. So hopefully some of these skills are things that we've seen before, so it's nothing extremely new to you. So this we talked about yesterday. We talked about parent functions and graphs. So if I were to graph this first one and plug in these three numbers, I would get a 0, a 2, and a 4. If I graph it, it would have looked like this line. If I would have graphed the second one using those three same x values, I would get a 3, a 5, and a 7. So I'd have this line here, and if I use the same three x values over here, I'd get a line that has 0 and a -4, 1 and a -2, 2 and 0. So I would have ended up with this line here. So questions that we had were, how are they related? Hopefully, again, we can see that their slopes are the same. The only thing different is the y-intercept. And hopefully we can see that the y-intercept of this first one was 0. The y-intercept of the second one, this red one, was 3, which came from there. And the third one, the y-intercept, was right here. So the question is, how could you graph without making a table? Hopefully we could see that if we started by putting the y-intercept on and used the slope from there, we could graph these lines. So we'll explain a little bit more of that in just a second. But first, hopefully we can find slope and y-intercept from equations. So for instance, hopefully we can see that the slope of this first one is with the x, so the slope would be a -2. The y-intercept of this one would be a 7. If I look at this one, the slope is with the x, and this should say y equals 6x plus 11. It's kind of off the page, but the 6 is the m, which is the slope. The b is the 11, or the y-intercept. Okay? So if we were to graph this one, the two things you need to pick out, you need to pick out the slope, you need to pick out the y-intercept. So our y-intercept is -2, and the m, how many x's are there? There's 1. So the thing that I want us to think about is start with and then increase or decrease by. So this b represents our starting number, and that's a -2. So that's where we start on the y-axis. So that's our y-intercept, so we're starting at a -2. A slope of 1 means 1 over 1, which means you're going to go up 1 and over 1. Up 1 over 1. Up 1 over 1. So I'd have this line formed right here. You could also go down 1 and back 1. Okay, that would form the same line. Okay, so if I take a look at this one, we have y equals 3x plus 1. Our slope is 3. Our y-intercept is 1. So our slope is a 3 over 1. So if we start with the y-intercept, I start with a 1. Then what's it do from there? It goes up 3 and it goes over 1. It goes up 3, it goes over 1. If you want to work backwards, you could go down 3 and back 1. So we got this line formed right here. Okay, next one. We've got a y equals -1x or -x minus 1. So our slope, if it's a -x, that's the same thing as a -1. And the b is a -1. So our start on our y-axis is a -1. Slope of a -1 is like down 1 over 1. So I go down 1 and over 1, down 1 over 1, down 1 over 1. You could also go up 1 and back 1, up 1, back 1. So I'd end up with this line. Okay, last two we're going to look at. So our slope of this one is a 1/2. Our y-intercept is a 2. So where do you start? You start at a 2. Slope of 1/2 means you go up 1 and you go over 2. Up 1, over 2. Up 1, over 2. You go down 1 and back 2 as well. So I'd end up with this line right here. And the last one today, slope is -4/5. and the y-intercept is -5. So I start at a -5, and it's a -4/5, so I go down 4 and I go over 5. Now I don't have room to go any further, so then in this case I'd go up 4 and I'd go back 5 the other way. So I'd end up with this line here. So hopefully that's making sense to us. If not, you better come with some questions tomorrow in class. Hopefully you have a good evening, and that is a wrap.